Welcome to this video on how artificial intelligence helps Mars rovers explore the red planet. Mars is one of the most exciting destinations in space exploration. It is close enough for robotic missions, but still far enough to challenge everything we know about engineering, science, and survival. Today, Mars rovers are no longer simple machines waiting for commands from Earth. With artificial intelligence, they can see the environment, detect hazards, choose safer routes, manage energy, analyze rocks, and support scientific discovery. In this video, we will explore how AI is transforming Mars rovers into intelligent planetary explorers. Let's begin with one fascinating question. Can a robot think on Mars? Of course, a rover does not think like a human. It does not have emotions or imagination. But with AI, it can make intelligent decisions based on data. When a rover sees rocks, slopes, sand, or unknown terrain, it must decide what to do next. Should it continue forward? Should it stop? Should it turn left or right? Should it send a warning to Earth? AI gives the rover the ability to analyze the situation and choose the best action. This is the beginning of intelligent exploration on another planet. Mars is not like driving on a road on Earth. There are no highways, no GPS, no repair stations, and no rescue team waiting nearby. The surface is full of rocks, craters, steep slopes, soft sand, dust storms, and extreme temperature changes. A small mistake can become a serious problem. A rover can get stuck, damage its wheels, lose energy, or miss an important scientific target. This is why Mars exploration is so difficult. AI helps the rover understand this unknown world step by step. It turns raw images and sensor data into useful decisions. One of the biggest challenges of Mars missions is communication delay. Earth and Mars are millions of kilometers apart. A signal from Earth to Mars can take several minutes to arrive. Depending on the distance between the two planets, the one-way delay can be around 4 to more than 20 minutes. This means engineers on Earth cannot control a Mars rover like a remote control car. The rover must have some ability to act by itself. AI helps solve this problem by giving the rover autonomy. Instead of waiting for every instruction, the rover can make safe local decisions and continue the mission more efficiently. AI gives the rover one of the most important abilities in space exploration, autonomy. Autonomy means the rover can perform some tasks by itself. It can see the environment, detect hazards, choose a safe route, save energy, and select scientific targets. This does not mean humans are removed from the mission. Humans still define the mission goals. Scientists still decide the big questions. Engineers still monitor the system. But AI helps with the details. This makes the mission faster, safer, and more productive. Before a rover can move safely, it must first understand what is around it. This is where computer vision becomes very important. Computer vision allows the rover to process images from its cameras and recognize objects in the environment. It can identify rocks, slopes, shadows, sand patches, and possible obstacles. For humans, looking at an image and recognizing a rock is easy. But for a robot, this requires advanced algorithms. AI helps the rover convert camera images into environmental understanding. In simple words, AI helps the rover see Mars. Mars is full of hazards. Large rocks can block the rover's path. Steep slopes can make driving dangerous. Soft sand can trap the wheels. Rough terrain can damage instruments. Even a small obstacle can create a serious risk. AI helps the rover detect these hazards before they become problems. The rover can analyze the terrain, mark dangerous areas, and select safer paths. This is very important because every rover is extremely valuable. A Mars rover may take years to design, build, launch, and land. Protecting it is essential. AI acts like a safety system for exploration. Once the rover detects hazards, the next step is path planning. There may be many possible routes across the Martian surface. Some routes are short but risky. Some are safer but require more energy. Some may lead to better scientific targets. AI compares these options and chooses the best path. The goal is not simply to move quickly. The goal is to move safely, efficiently, and intelligently. This is why path planning is so powerful. With AI, the rover can explore more ground, avoid unnecessary danger, and reach scientifically important locations with higher confidence. On Mars, energy is extremely important. Every movement costs power. Every instrument consumes electricity. Communication with Earth also requires energy. Some rovers use solar panels, but dust can reduce solar power. Weather conditions can change. The rover must carefully manage its battery and daily activities. AI can help optimize energy use. It can decide when to move, when to stop, when to collect data, and when to save power. This is especially important for long missions. A rover that manages energy well can survive longer, travel farther, and collect more scientific data. Mars is full of rocks, but not all rocks are equally important. Some rocks may contain clues about water, volcanic history, climate change, or even possible past habitable environments. AI can help identify which rocks are scientifically interesting. By analyzing images, chemical signals, and spectral data, AI can highlight targets that deserve further study. AI does not replace scientists. It helps scientists focus their attention on the most valuable discoveries. Every rover mission produces a huge amount of data. Images, spectra, temperature records, terrain maps, chemical data, and engineering measurements are collected continuously. AI learns from this data. It can detect patterns, classify objects, compare new observations with previous ones, and improve decision-making. This is one reason AI is so powerful in planetary exploration. Mars is complex, and the data is massive. Humans may not be able to analyze everything quickly, but AI can scan large data sets and find useful information. Every image becomes knowledge. Every measurement becomes insight. A successful Mars mission is not only about machines. It is about teamwork. Humans define the mission goals. Scientists ask the big questions. Engineers design the rover and monitor its health. AI supports the mission by handling detailed analysis and decision support. This partnership is very powerful. AI can suggest a route, detect a hazard, analyze data, or identify a scientific target. Then humans can evaluate the result and make higher-level decisions. So the future is not human versus AI. The future is human plus AI. Together, humans and intelligent machines can explore Mars more effectively than either could alone. Future Mars missions may not rely on only one rover. Instead, we may see teams of intelligent robots working together. One rover may map the terrain. Another rover may collect samples. A drone may fly ahead and scan the landscape. A small robot may enter dangerous areas that are too risky for a large rover. AI can coordinate these robots. They can share data, assign tasks, avoid hazards, optimize routes, and work toward common mission goals. This is the future of planetary robotics, not one machine alone, but a team of intelligent explorers working together. One of the most exciting roles of AI is scientific discovery. Mars rovers are not only vehicles. They are mobile laboratories. They carry cameras, drills, spectrometers, microscopes, and chemical instruments. These tools help scientists understand the geology and history of Mars. AI helps prioritize the most important observations. For example, when the rover finds an unusual rock, AI can help decide whether it deserves more detailed analysis. This saves time and increases the chance of discovery. In space exploration, every minute and every measurement matters. AI helps us use them wisely. Mars is unpredictable. A route that looked safe yesterday may become risky today. Dust may reduce visibility. A slope may be steeper than expected. A rock may block the planned path. AI allows the rover to adapt in real time. Adaptive navigation means the rover can update its plan when conditions change. Instead of following one fixed route blindly, the rover can adjust. This is very important because Mars is not a controlled laboratory. It is a real, changing, uncertain environment. AI gives the rover flexibility, and flexibility is essential for survival on Mars. To explore Mars safely, the rover needs maps. Not only flat maps, but detailed 3D maps of the terrain. AI can help build 3D maps from camera images, stereo vision, laser measurements, and other sensor data. These maps show the shape of the ground, slopes, rocks, depressions, and possible obstacles. With 3D mapping, the rover can better understand where it is and where it should go. This helps with navigation, hazard avoidance, route planning, and scientific interpretation. In simple terms, AI helps transform the Martian surface into a digital landscape the rover can understand. An autonomous driving system combines several AI abilities. First, the rover needs perception. It must detect rocks, craters, slopes, and hazards. Second, it needs localization. It must estimate where it is. Third, it needs planning. It must choose a safe and efficient path. Finally, it needs control. It must move its wheels correctly and follow the selected path. All of these steps must work together. This is not easy. Mars is rough, distant, and uncertain. But when perception, localization, planning, and control are combined, the rover becomes a much more capable explorer. Obstacle avoidance is one of the most practical and important AI functions. The rover must detect obstacles and avoid them automatically. If a large rock is in the path, the rover should not continue straight. If the ground looks unstable, it should choose another route. AI can identify obstacles, estimate risk, and select a safer path. This protects the rover and helps the mission continue. Obstacle avoidance may sound simple, but on Mars it is extremely important. There is no mechanic nearby. There is no second chance for serious damage. AI helps keep the rover alive. AI is also useful for analyzing soil and terrain properties. The rover can study the surface composition, particle size, slope, roughness, and geological features. This information is important for both science and engineering. For science, soil analysis helps us understand the history of Mars. It can tell us about past water activity, volcanic processes, mineral formation, and environmental change. For engineering, terrain analysis helps the rover drive safely. Soft soil may trap wheels. Rocky terrain may cause damage. Steep slopes may be dangerous. AI connects science and safety in one workflow. Mars has weather, and Martian weather can be dangerous. Dust storms, wind changes, temperature drops, and reduced sunlight can affect rover operations. AI can help monitor weather conditions and predict possible risks. For example, if dust is increasing, solar power may decrease. If temperature drops too much, some systems may need protection. If wind conditions change, the mission team may adjust the plan. Weather monitoring helps the rover prepare. This is especially important because Mars missions must operate for months or years. AI helps the rover survive not only the terrain, but also the environment. A Mars rover has many scientific instruments, but it cannot use all of them all the time. Each instrument requires energy, time, and planning. AI can help decide which instrument to use and when. Should the rover take a photo? Should it use a spectrometer? Should it drill into the rock? Should it use a microscope for close-up analysis? AI can help prioritize actions based on mission goals and available resources. This makes the rover more efficient. Smart instrument control means better science with limited time and energy. A Mars rover cannot send unlimited data back to Earth. Communication bandwidth is limited. Energy is limited. Time is limited. So the rover must decide which data is most important. AI can help compress data and select high-priority information. Instead of sending everything, AI can identify the most valuable images, measurements, and scientific results. This is extremely useful for deep space missions. The rover collects a lot of raw data, but AI helps choose what Earth needs most. In this way, AI improves communication efficiency and scientific value. The farther we go into space, the more autonomy we need. Mars is already far from Earth, but future missions may go even farther, to asteroids, icy moons, and outer planets. In these missions, communication delay becomes even more challenging. AI-enabled exploration allows spacecraft and rovers to make smart decisions without waiting for constant human instructions. This does not mean humans lose control. It means humans design the goals, while AI helps execute the mission locally. Long-distance autonomy is one of the keys to the future of space exploration. The farther we explore, the smarter our machines must become. Before AI is used on Mars, it must be carefully tested. Space missions are expensive, and failure can be devastating. So AI systems must be trained, tested, validated, and verified before launch. Engineers use simulations, laboratories, test fields, and mission scenarios to evaluate AI behavior. They test how AI responds to rocks, slopes, dust, low energy, sensor errors, and unexpected situations. This step is critical. AI must be reliable, explainable, and safe. Before a rover can trust AI on Mars, scientists and engineers must trust it on Earth. AI is not only useful for exploration. It is also useful for monitoring rover health. A rover has motors, wheels, batteries, sensors, communication systems, and scientific instruments. Any of these systems can develop problems. AI can detect unusual behavior in real time. For example, it may identify high motor temperature, unexpected vibration, abnormal power consumption, or sensor failure. Early detection is extremely important. If the rover detects a problem early, the mission team can respond before the issue becomes serious. AI works like an intelligent warning system. Self-diagnostics means the rover can continuously check its own health. It can monitor motors, wheels, batteries, sensors, and communication systems. AI can compare current behavior with normal patterns and detect early signs of failure. This is very important because Mars rovers operate in harsh environments for long periods. They face dust, cold, vibration, rough terrain, and mechanical stress. Self-diagnostics helps keep the rover safe and functional. A healthy rover can continue exploring. A rover that understands its own condition can survive longer and perform better science. Mars rovers are not only exploring for science, they are also preparing the way for future human missions. Before humans arrive on Mars, we need to understand the terrain, resources, weather, radiation, and possible landing areas. AI-powered rovers can help collect this information. They can map safe routes, identify useful materials, study soil conditions, and search for locations suitable for future human activity. In this way, rovers are the first explorers. They go before humans, reduce uncertainty, and help us prepare for the next great step in space exploration. The future of Mars exploration will be intelligent. AI-powered robots will explore larger areas, collect more data, and make better decisions. They may work in teams, coordinate with drones, support astronauts, and help build early infrastructure. They will not replace human curiosity. Instead, they will extend it. AI allows us to explore places that are too distant, too dangerous, or too complex for traditional methods alone. Mars is only the beginning. As AI becomes more powerful, our ability to explore the universe will become greater than ever. The future of space exploration is a partnership between AI, robotics, and humanity. Robots can go first. AI can help them make decisions. Humans can ask the big questions, interpret discoveries, and define the vision. Together, we can explore beyond our limits. Mars may become a testing ground for this partnership, a place where intelligent machines and human creativity work together to understand another world. This is not just about technology. It is about the future of exploration. AI and robotics may help humanity become a multi-planetary species. Thank you for watching this video on how AI helps Mars rovers explore the red planet. We have seen how AI supports navigation, hazard detection, energy management, scientific discovery, 3D mapping, weather monitoring, instrument control, anomaly detection, and future human missions. The message is clear. Mars exploration is becoming more intelligent. AI is helping rovers move safer, work smarter, and discover more. The journey to Mars has just begun. Please like this video, subscribe to the channel, and follow the next episode in this space exploration series. See you in the next video.